In this video, I'm going to be explaining what slope is and then how to find the slope between 2 points. Let's define slope first. Slope is a ratio. It's comparing two things. And that ratio is describing the steepness of a line. So whether it has an incline or a decline. And that ratio is going to describe the steepness of it or the slant of it. It could also be used to describe the rate at which something is changing, or rate of change is how it's usually referred. In geometry, we're going to talk a lot more about slope in reference to a line or the steepness of a line. Algebra classes tend to talk more about that rate of change when they're talking about functions or equations describing relationships. So let's be able to tell that this line right here has a steeper slope. It's going to have a greater slope. It doesn't matter if it's more negative or more positive. It's just going to be greater. But in an algebra class, you might see something like this. For example, if a pizza costs $5, how much does X amount of pizzas cost? So you could write an equation that says Y is going to be your total cost, X is going to be the number of pizzas, so Y equals 5X is going to represent the cost of X amount of pizzas. So I would just plug in my number of pizzas into X, multiply by 5, and I would get my total cost. So your cost is changing by a rate of $5 for every pizza that you buy. So in that case, the slope is the coefficient of that variable, or the number in front, and the slope is representing the rate of change of our equation or our relationship. There are 4 ways to represent slope. There are actually more, but we're just going to focus on these 4. M is the variable we use when we describe slope. We'll see that used in equations of lines. It is describing a ratio, so a fraction comparing two things. It's comparing the rise to the run. So we could talk about slope as a rise over run. We could also talk about rise as being the change in our vertical or the change in our height. And that is represented by subtracting our y coordinates. The run is describing the horizontal change or a change in our x values. And that can be evaluated by subtracting our x coordinates. So this is our slope equation, y2 minus y1 divided by x2 minus x1. And we're going to use that to find the slope between 2 points. So in these examples, we're going to find the slope between the 2 points, that incline value or decline value, and then we're going to be able to describe what type of line it is based on whether the slope is positive, negative, 0, or undefined. So in our first example, we could take our coordinates. We got 2 points. So I'm going to call my first coordinate pair x1 and y1, and my second coordinate pair x2 and y2, although it doesn't matter which you assign your 1s and 2s to, as long as they go with the same pair. So we can't mix up x1 and y2. We got to say x1 and y1 in one pair and x2 and y2 in another pair. Then we're going to plug it into our formula. The slope formula is subtracting our y values over subtracting our x values. So I assigned 7 to y2 and I assigned 2 to y1. So I'm going to do 7 minus 2 on the top. That's going to be our change in y or change in our vertical. And then on the bottom, I assigned 3 to x2 and negative 5 to x1. So 3 minus negative 5. Be careful when you're doing that subtraction. And our result would be 7 minus 2 is 5 on top. 3 minus negative 5 on the bottom is 3 plus 5, so that's 8. Excuse me. So our slope is 5/8, or the incline, because it's a positive slope, means that for every 5 units that I'm going up in a vertical fashion, I'm running or going in a horizontal direction 8 spots. Or for every 8 spots that I run horizontally, I'm rising 5 spots. So that's describing the slant or the incline of this line. Because it has a positive slope, we say that this line is increasing. It's going up because it has a positive slope. Let's do the second example. 2 more points. Again, assign x1 and y1 and x2 and y2. So y2 is 2, y1 is 4, so I'm going to do 2 minus 4 on top. On the bottom, 0 is x2 and negative 6 is x1, so I'm going to do 0 minus negative 6 on the bottom. 2 minus 4 is negative 2, and 0 minus negative 6 is 0 plus 6, which is 6. And then we always want to reduce a fraction, and we always want to reduce a slope. So even though negative 2, 6 is the slope, we want to always simplify and say that the slope is negative 1/3, just dividing top and bottom by 2. So we have a negative slope. When I plot these points and connect them, I can see that my line is going down. So that matches with a negative slope. And we describe that line as a decreasing type of line because it has a negative slope or because it's going down from left to right. Two other special examples here. These are our special lines, horizontal and vertical lines. If I try and find the slope of a horizontal line, let's see what happens. 4 is going to be my y2. 4 in this coordinate pair is going to be my y1. So if I do 4 minus 4 on top, I get 0 on top. And 0 divided by anything, doesn't even matter what the bottom is, it's going to give me a value of 0. But even if we simplify the bottom, we're doing 5 minus negative 3, we get positive 8. 0 divided by 8 is 0. Anytime the top of a fraction is 0, the whole fraction is 0. So what is this saying? It's saying that it doesn't rise at all. It has a 0 rise, so it's not going up or down. It could run forever. It doesn't have to just run 8 units. That could be infinity. It wouldn't change anything. The slope of a horizontal line is always 0 because we're talking about the incline or the decline. It's not going up, it's not going down. So the slope is 0. The slope is measuring an incline or a decline. If it doesn't have that, then it has a 0 slope, and we're talking about a horizontal line. Another trick you can use is if your y values are the same, that means that you're not going up or down, and that means you're going to have a horizontal line. So you can really tell just in the coordinate pair that we're talking about a horizontal line, and that has a 0 slope. In this last example, y2 is going to be negative 3, y1 is negative 8, so I can do that. I can simplify negative 3 minus 8 and get negative 11. But when I subtract my run, or my difference in my x values, they have the same x values. So 5 minus 5 is 0. So that means that I'm not running, I'm not changing in a horizontal direction at all. So I must just be going up and down. It doesn't matter what our rise was. It could be infinite as well. As long as it's not running or having a horizontal change, it's going to be a vertical line. And a vertical line we describe as having an undefined slope. Oops, let me fix that real quick. So we use the word undefined because we cannot define the slope if it's just straight up and down. I've had some teachers tell me that you can imagine a slope as something you can walk on. So I could walk on these lines. I'm walking uphill. That's a positive slope or an incline. I could walk on this line from left to right, and I'd be going downhill, or I would have a negative slope or a decreasing line. I could walk on this horizontal line, and I wouldn't have to try very hard. It's just a straight path. I'm not going up or down. I'm staying flat, so that's a 0 slope. But if I try and walk on a vertical line, I fall down and I die. It's kind of morbid, and I'm undefined. Maybe that's one way that you can remember that a slope of a vertical line is undefined, and a slope of a horizontal line is 0. And if a line has a positive slope, it's increasing. If a line has a negative slope, it's decreasing. So there's a slope between 2 points and types of lines based on their slope.